Hello, today we're starting Unit G. I broke up Section 6.1 into two sections, Part 1 and Part 2. So today we're going to talk about evaluating roots and using rational exponents. In general, for an integer n greater than 1, if b to the n equals a, then b is considered to be the nth root of a. So what happens is if we look at this and we wanted to get b all by itself, we would have to nth root both sides because we don't know if that's a squared. If it was a squared, we square root. If it was a 3, we would cube root both sides. So that's where this comes in. N is the index of the radical. You can also write an nth root of a power as a power of a. If you assume the power of a power property applies to rational exponents, then we have the following is true. So basically think about your rules of exponents. If I have a to the 1/2 raised to the second power, it just becomes a to the first, which is a. Same thing when we have a to the 1/3. We raise it to the third power, remember, because we're multiplying. So our rules of exponents apply, it's just now we're going to see some exponents as fractions. So because a to the 1/2 is a number whose square is a, you can write the square root of a as a to the 1/2. So the cubed root of a can be written as a to the 1/3, and so on, okay? And we're going to talk about this when we do the examples as well. Okay, and then we have some rules about this. If n is an even integer and a is less than 0, there's no real roots. If it's equal to 0, there's going to be 1. And if it's greater than 0, there's going to be 2. And we'll talk about that. And if it's an odd integer, if it's less than 0, there's 1 real root. Equal to 0, 1 real root. And greater than 0, 1 real root. And you'll see what I'm talking about and why that happens. So when it's even, it's a little bit more particular. When it's odd, it's not. Okay, so a rational exponent does not have to be of the form 1 over n. We can have a fraction such as 3/2, okay? You can have a fraction as a negative 1/2. Just we're going to practice converting between rational exponents and radicals. So here is what you need to know. Rational exponent form would look like this. X to the m over n. If I had this and I wanted to write it in radical form, the bottom number is what root you're taking. So it'd be the nth root of x raised all to the m power. Okay, you do need to know these two. Very, 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 very important, and we'll convert between the two. You also need to know this chart I'm about to fill out, because in this section we are not allowed to use calculators, not even scientific calculators. We're going to make a note card to help you remember this in class tomorrow. So basically, if I take 2 and I square 2, I get 4. If I cube 2, I get 8. If I take 2 to the 4th power, I get 16. 2 to the 5th power is 32, and 2 to the 6th power is 64. For 3, we need to know up to the 5th power. For 4, we only need to know up to the 3rd power. These are the ones that you should have memorized. Otherwise, you're going to be doing a lot of multiplication, and you're not going to be able to go as quick on your test and quizzes. The third, when we take 5 as our base, we only need to know it to the 3rd power, and then 6, just 2 of them is good enough. Okay, we don't need to know these ones, and like I said, we'll make this note card just like this in class tomorrow. Okay, so memorize all this stuff up here. Very, very, very important. I want you to highlight it, circle it, star it, whatever you need to do on your sheet. Okay, let's go ahead and take a look at the first example. So all we're doing here is we're going to convert. We're given radicals and we're going to convert it to a rational exponent. So I want our exponent to have a fraction. Okay, so remember what I said. This is our base, and we're going to use the root as the bottom number, and it's not raised to any power, so it's 1 over 5. This one, 10 is our base. 3 is going to be our bottom number because that's the root we're taking, and it's raised to the 7th power. Okay, pretty easy, right? So you just need to know to be able to do that. And then this one down here, we're going to convert using radical notation. So the bottom number, remember, is our root. So it's going to be the 4th root of 5. It's raised to the 1st power, so I don't need anything on the outside. This one, we're going to take the 5th root of 14, but because of the top number being a 2, we're going to raise it all to the 2nd power. Pretty easy, right? So remember, the denominator of the exponent is what root we're taking. Square root, cube root, 4th root, 5th root, 6th root. Okay, let's go ahead and try these problems. Now, these problems can get tricky depending on how we do it. I like to look at it in radical form. It just helps me. So I think to myself, what number times itself 5 times gives me 32? So when I do that, the answer is 2. How do I know that? Because I have my chart memorized. If we look in the 2 row and the x to the 5th column, it's 32. Now, because there's a negative underneath and it's to the odd power, it's negative. A negative times a negative times a negative times a negative times a negative is negative. Now, this would have been an even number. My answer is no solution because I can't take the even root of a negative number. Okay, over here, the 5th root of 32 then is just positive 2. Okay, here, the 6th root of 64 is also 2. Okay, because 2 to the 6th power is 64. This one, it's a negative and an even. So because of that, because this number is even, it's no solution. So these ones aren't so bad, right? Okay, now here's what I don't like looking at as a rational exponent. I prefer to transfer. That's just my preference. So I prefer to do this. The 4th root of 256. The 4th root of 256, if you look up at your chart, is 4. Okay, now the 4th root of negative 256. Because this is an even number and this is a negative, we have no solution. Okay, let's try these next 4 problems. Okay, now this gets a little trickier. So the first thing you want to do, and like I said, I don't like to look at it like this. So I like to do the 5th root of negative 243. Once I get that answer, then I'm going to cube that answer. So the 5th root of negative 243 is negative 3. Then I'm going to cube negative 3. So negative 3 times negative 3 times negative 3 is negative 27. Okay? Okay, look at this one. We're going to take the 5th root of 32, and then we're going to raise that to the negative 3rd power. Now, if I take the 5th root of 32, I get 2. So 2 to the negative 3rd power. You don't want negative exponents. Remember our rules of exponents. So we're going to put this whole thing on bottom. So I have 1 over 2 cubed. I will accept this as the answer, but 2 cubed is pretty easy to know. So it's just 8. Okay, so watch the negative exponents. Let's do another one like this. Okay, so this is the form I prefer to see it in, obviously, because the 2 problems above, I rewrote it. Okay, so I'm going to take the 4th root of 81. When I take the 4th root of 81, I get 3, and then I have to cube 3, so I get 27. Here, I'm going to take the cubed root of negative 27. When I do that, I get negative 3. It's raised to the negative 4th power. Now remember, moving it doesn't change this negative. It only changes this negative. So I'm going to put 1 over negative 3 to the 4th power. So when I do that, you can leave it like that, but since I want you to know that chart, I would rather you multiply it out, so I get 1 over 81. Negative 3 times negative 3 times negative 3 times negative 3. Okay, I would like you to go ahead, pause the video, try the U-Try without using a calculator. You are having a quiz on this section with no calculator. So the practice in the notes, the practice in class should all be without your calculator. And then if you have any questions, comments, or concerns, go ahead, write it at the bottom of the video, and I will see you tomorrow in class.